let's go ahead and do example 2. The means of the tomato yields under the 5 mulching conditions are represented by the following: the mean of the bare, mean of the ground, mean of plastic, mean of straw, and mean of compost. We will conduct a hypothesis test to determine if all the means are the same or at least one is different. Use a significant level of 5%. Test the null hypothesis that there is no difference in the mean yields among the 5 groups against the alternate hypothesis that at least one mean is different from the rest. Okay, so this one gives you your null and your alternative. And let's look at the data. So here's your data, and it's put in summarized. Now notice ground cover and plastic don't have the same sample size as bare, straw, and compost. That's okay with ANOVA. If it gets to be too many differences, then that could affect it. But for these smaller samples, it doesn't hurt it as bad. So let's go look. Example 2, hypothesis. All right, well, we've just got those, but I went ahead and wrote them that the null is the mean of B equals the mean of G equals the mean of P equals the mean of S equals the mean of C. So why did I do the letters? Well, the letters show me the different ground covers, so I'll know better what to look at. And again, the alternative is that they're not all the same. Again, it doesn't tell me which ones are different. I can make assumptions, but there's further tests I have to do to see what those are. All right, so in Minitab, let me show you what I did. So Minitab, if you look here, I have all of the summarized data. And I actually also have it in raw form. Okay, so the first way I'm going to do it, let's do it as summarized. So I'm going to talk about this data right here. So I go up to Stat, I go over to ANOVA, and I do One Way. So again, I do responses are in separate columns for each factor. Why? Because I look over here, I've got bare, ground cover, plastic, straw, and compost. They each have their own column for each type. So again, if I want to go call to them, I need to go click on bare, ground cover, plastic, straw, and compost. You don't have to put them in order, but I do to make it easier on myself. Then I hit options. Again, assume equal variances, 95, since my level of significance is 5%, and two-way because I want the confidence intervals. I hit OK, and I hit OK. All right, so if I look here, again, I have the hypotheses. I have my 5 factor levels to make sure that I have them all. I have my ANOVA table. F value is 7.11, P value is 0.0. I have my R squared again, which we'll get to in regression. And then here I have all of the types with the sample sizes and the means, standard deviation, and the confidence interval. And then I have my graph. Okay, something interesting is going here on the graph. Let me go to the PowerPoint where you can see it better. And again, I have all the instructions here in the PowerPoint to help you if you get confused. All right, let's look at this graph. All right, well, bare didn't give me as good of yields as compost, straw, and plastic. Even ground cover didn't give me as good as the others. So I'm thinking that, hey, something might be going on here. Even though you have that hunch, you still need to test it to see if there's a significance difference. Because sometimes it'll look significant, but it's not. All right, so again, I'm going to quickly go over, well, what if I have raw data? So again, I go to Stat, ANOVA, One Way, and then this is a little different. Then I'm going to put it as the response data is in all one column, okay? And this is the good thing. Let me show you a trick that might help you. Oops, let me get out of there. Okay, when I'm in the response, did you see that? Because when I got into factor, it gave me type, but when I get in response, it didn't. It didn't include type because of that T right there. Because Minitab knows when you do words, those are text and they're not numbers. So that could help you. So response is yield, factor is type. Options, again, they're going to be the same. Check assumed equal variances, 95 and 2-sided. Hit OK and OK. And again, if I quickly go down and look, it gave me the exact same thing, even gave me the same graph. So I'm good to go. So let's keep going. Right? So I go back to my PowerPoint. And the reason is it did it a little differently. Let's go back and look at that graph because some people might be confused because I didn't put it in there. It did it slightly different because it just did the order different because of how the data was in. Here's bare, here's ground, and here's the other. Depending on how you put your data, your graph might look different. It's not a big deal. They're going to still show the same. I did it this way, and what it does is it puts them in alphabetical order, where the first way, it did it based on the way I gave it to it. And let me go back and show you. It gave it that way, the way I put it in. So it is a little bit different, but don't worry about that, okay? So I'm going to keep going. I've got all my stuff, so let me go with my conclusion. All right, so remember, my F value was 7.11, P value is 0.010. All right, so I go here. 0.010 is less than or equal to 0.050. So because P value is less than my level of significance, and again, if that is confusing you, always remember to put the decimal. Because if I looked at it this way, I'd say, oh, 10 is bigger than 5. Then I'd fail to reject it. But remember, I need to have the same number of decimal places. So 10 equal to, or is it less than, equal to, or greater than 50? It's less than, so I reject the null. So what that means is I reject the null, and my alternative is true. So not all the means are equal. So my conclusion, at the 5% level of significance, there is strong evidence that the difference in the mean yields from the mulching conditions are unlikely to due to chance alone. We may conclude that at least some of the mulches leads to different mean yields. And think about it this way. I'm going to go back to the graph. So if I plant stuff in a garden and I leave it without anything covering the soil, I'm not going to have the same yield as if I put something down to protect it from the elements, the rain, the sun, animals, anything like that. Even ground cover gives me slightly better than bare coverage. Plastic is a little bit better, is a lot better, so is straw, and so is compost. An interesting thing about statistics, here's your interesting fact. Statistics was actually started in the UK with agricultural. And a lot of things they used to do is they had huge books of just like yields from different growing seasons, different growing times, and these kinds of mulches and stuff. And that's where they started statistics, is to try to figure out how to feed more people with the same amount of land. So again, based on that graph, I thought something was going on. And when I concluded, yep, something's going on. But again, you can't tell me which one is different. You can show me the means, the standard deviations. I have to do another test to know for sure which ones are different than the rest.